In 13.154, we have a block that's going to be dropped down onto this, around this chain to hit this bar, and the bar is connected to this beam up here. The weight of the beam and the chain and the bar is all 240 pounds. The weight of the block, which I'm calling a little b right there, is 60 pounds, and the height that's dropped from is 5 feet. So conservation of energy would lead us to the velocity that the block is going to hit the end of the chain there with a speed of square root 2gh, and it's minus because it's downward. We're to find the impulse applied to C being the chain, and the energy lost. For a perfect collision, perfectly rigid beam in the first place, so in part A, and then for elastic springs in part B. The momentum impulse on the block is going to be the momentum of the block start off with plus the impulse applied to it, and it comes to a zero stop. So the impulse on C, which is going to be equal to the minus the impulse on the block, is going to be equal to WB over G times V, and plug numbers in, you get the impulse of the chain then as a minus 33.4 pound-seconds, and it's downward, which you expect. The energy lost is very simple. It's just all the kinetic energy the block had is gone now, so the energy lost is just from this right here, and that's going to be 300 foot-pounds. Now, if you have elastic springs, we have to look at conservation of momentum then. The momentum of the system of the block and the beam together will be equal to the final momentum of the block and the beam together. What you have initially then is just the momentum of the block, because the beam has no velocity. And then the two stick together, so it's a perfectly plastic collision with a single velocity, and when you solve for that single velocity, you get V over 5. Then we're going to look at the momentum impulse on B again. Here's object B with its momentum. There's its impulse. Here's its final momentum right here, V prime being this. And so, again, remember that the impulse applied to C is the negative of the impulse applied to the block. And so you end up with this expression then coming from this over here. And you get the impulse applied to C as minus 26.7 pound-seconds. And then to get the energy lost, you just need the initial kinetic energy of the system, which is the block only, and then minus the kinetic energy of the block and the beam right after the collision took place, and that's that term. And you plug all your numbers in, you get 240 foot-pounds.